Today we are going to do everything about single surface refraction that includes curved surface as well as flat surface. First, let's have a look at this nice video. Just look at that, guys. Without the water, the arrow mark in the glass is towards the right side, but the moment you pour some water, look at that arrow mark, it turns towards the left side. This can be explained just by refraction through curved surfaces. And I'm pretty sure by the end of the class, you would have understood this. And if you understood it, then put your answers in the comment section below. So we're going to see all the cool phenomena, even the optical fiber network, how it works. I'm pretty sure you have some idea, but we are going to see some really cool problems on that as well. So all this with me, Shreyas, your master teacher for physics, going live at Vedantu on this very own channel of yours, Enthuse. It's a very special, unique channel because I don't know many channels which teach for JEE in completely English. So we have come up with this plan so that we can cater to all those students who want to prepare for all the examinations like BITSAT, KVPY, boards, and obviously JEE mains and advanced, and that too in English medium. So welcome aboard, welcome all the new family members to this channel. And I'm Shreyas, I'm the physics master teacher, and I have been teaching students for quite some time now. And luckily, many of my students have done exceptionally well in the JEE mains as well as advanced and other examinations like KVPY. And you can see that many of my students are even in IITs and NITs with not just any ordinary ranks, but in fact, all India rank less than 100. Yes, that's right, 2-digit all India ranks. And I really hope you too will be there one day. And with the help of this channel and with the amazing master teachers that you have over here, I'm pretty sure you will do well. And if you still want to get in touch with me, you can contact me on Shreyas_Vedantu. That's my Instagram handle. Hi Fida, Samiksha, Romil, Priyanka, Aishwarya, Ankit, Hoin, Linin, Ira, Kirito, Albert, Prem, Bhargav, welcome. Hi Fida, hi Ira, hi Prem, welcome. Good evening. Hi Bastin, welcome aboard. All the minions out here. So guys, introduce yourself, and if it is somebody's birthday, please let us know so that we can wish you a very happy birthday, or if it's a special thing that you did in the school, college, please let all your friends know on Enthuse, because you have to make friends, you have to help each other, and there should be that healthy competition on this channel. That's what we want to do. Very good, very good. Yes, thank you so much for all the love, all the hearts, guys. And I saw all your messages on Instagram that you sent me. Really, I'm blessed to have such students. Thank you. Romil will wish you tomorrow for sure. Definitely. And guys, I hope you have already liked the video. If you have not yet liked the video, come on, make that gray icon blue by smashing that like button. And if you have not yet subscribed to this channel, go hit that subscribe button, make that red disappear, make it into gray. Come on, do that. Yes, very good. Excelente. Okay, cool. So let's see the schedule for this week. Remember, there are KVPY sessions. Okay, tomorrow it's SA plus SX. Both 11th and 12th standard students can attend this session. I'll be covering, see, optics is the same, be it for 11th or 12th. For 12th, the problems are slightly tougher. For 11th, the problems are slightly easier. But we'll be taking into account both kinds of problems tomorrow, SA plus SX session. Yesterday, we started with optics. Today, refraction. And Friday, a big session, marathon session with previous year questions, prisms, lenses. So it's a big session. Come prepared with all your foods and all the juices that you want. And Saturday, we are going to have 12th standard or SX related session, very important session. All the important questions will be discussed out there. So marathons will be conducted by Shimon sir on Thursday. On Friday, I'll be doing it. Okay, and Wazim sir will be conducting it on Monday. So that's your marathon sessions, power-packed sessions for all of you. All right, so everybody is telling all their birthdays. Nice, interesting. Hi, Elamanchali, welcome. Good. And guys, be regular. Guys, I hope you realize that attending live classes is like nothing. I mean, you cannot compare it with recorded videos. I'm pretty sure many of you might have some prior commitments or maybe some clash of the classes. So because of which sometimes you might be missing something, but try to make it up for the live sessions as much as possible because it is fun. I'm pretty sure you understand that, because think about it, watching a live cricket match is obviously better than watching the recorded cricket match, even if you do not know the results, believe me. Okay, so let's start with refraction. Now, everybody would have seen this, putting up a pencil or seeing the pool's base, it appears shallow, or bending of light through different things when it passes through a different medium. We know light bends when it passes through different mediums. In fact, the speed of light is highest in vacuum, but when it passes through different medium like glass, water, or some other kind of transparent medium, then you will see the speed of light reduces and the light bends. So remember this, if light goes from a rare medium, okay, to a dense medium, then you will see if this is the incident ray, this is the normal ray, and this is the refracted ray, then you will see that the refracted angle is less than angle of incidence. It will be always less than it if it is going from rare to dense. Also, the speed will reduce. The speed of light will reduce, but keep in mind the frequency of light will remain the same, doesn't change. So very, very important, the frequency never changes, because if you pass green colored light, what enters inside water will also be green. It won't change to yellow or blue or something else. So the frequency of light obviously won't change. So if you pass let's say some other kind of light, blue color light, it will remain blue even inside water or glass. That's from dense to rare. And from rare to dense medium, I hope you guys are making notes simultaneously. Very, very important. If this is the angle of incidence and this is the angle of refraction, then angle of refraction is more than the angle of, oops, my bad, I should have written it opposite. So if this is dense and this is rare, the exact opposite of this, then it should bend away from the normal. And remember, again over here, the frequency remains the same. So very important, the frequency remains the same. If there was some speed which light had over here in the dense medium, as soon as it enters the rare medium, you will see that the speed will increase. Very, very important. Correct. Yes. Frequency is independent of density. Please understand, whenever I mention the word dense and rare, a lot of people think kg per meter cube. No, that's not what I'm talking about. Here, density means optical density. Optical density is completely different. It does not have units, but it's a relative concept. I will say a medium is denser optically if the light bends towards the normal. If the light bends towards the normal. And if it bends away, I will say it is optically less dense or optically rare as compared to the other medium. Yes, correct. Cool. Now, let's see Snell's law and all the relevant formulas, which probably you might know or not know, I don't know. So let's have a look at it. First of all, if this is angle of incidence, this is normal. Remember, all the angles are always measured from the normal. So this is your refracted ray, this is your incident ray, and also let's say the speed of light over here is C1, the speed of light over here is C2. Okay, this is, let's say, the medium number 1, and let's say this is medium number 2. Then the way Snell's law is written down is, if I take sine of I divided by sine of R, where is I? In medium number 1. Where is R? In medium number 2. That ratio will be speed of light in that medium, which is C1, divided by speed of light in that medium 2, which is C2, and that is also 1 mu 2. Very important, light is traveling from medium 1 to medium 2. So 1 comes first and then comes 2. If I write water mu glass, what does it mean? light is traveling from water inside of glass. That's how the numbering goes. But while pronouncing it, you are going to call this as refractive index of 2 with respect to 1. Refractive index of this with respect to 1. That's how it is pronounced. Remember that. Yes, correct. I hope this is clear. I hope this is clear. Well, Kirito, I will tell you about that light entering into prism. So in fact, it's not one frequency, there are many frequencies. So actually still the frequency remains the same. I'll be explaining that dispersion concept very soon. Yes, refractive index of 2 with respect to 1, Albert. Correct. Very good, very good, very good. Clear? Now, understand this is also mu2 divided by mu1. Look at this, 1 mu2 is mu2 divided by mu1. Now, when I say 1 mu2, okay, what is this exactly? This is always relative refractive index. But when I do not have any other subscript like the ones over here, these are just the absolute refractive index. So, who are you measuring it with respect to? Who are you measuring it with respect to? It is basically measured with respect to vacuum. Remember that. It is actually measured with respect to vacuum. Hello Khushbu, join in. Don't worry, you just missed probably 5 minutes. Just quickly replay and catch up. Yeah. Okay. Yes, Fida, correct. That's what you said is correct. Hi, VK. Okay, is this clear, guys? Very, very important stuff coming over here. And also remember, speed of light is frequency into wavelength. So this is very important. So C1 is F1 lambda 1 and C2 will be F lambda 2. Okay, all these are important formulas. All these are important formulas, yes, which you should know. Cool, let's get going. Let's get going then. Okay, chalo. I hope you have noted it down. These are some refractive indices of certain objects. Vacuum, obviously the refractive index is 1. I'm very good, Khushbu. I'm hoping that you are fine now, especially after the hospital. Yes. Air, look at that, it is very close to 1. So vacuum is as good as air because this is very close to 1. Most of the times we'll be neglecting it. Water is 1.33, or you can just say it is 4 by 3. Ice is also very close to it. Glass is 1.5 or 3 by 2. Diamond is 2.4, which is very high in value. So it is in fact used, for making the diamond sparkle. Very good, Chalu Pari. Don't worry, even VK channel is also from class 10th. Don't worry. Okay, but you can still attend. Even if you understand 40-50%, I will be very happy, Chilu Pari. Don't worry, again you will be learning with me next year. Okay, cool. Now, mu1 is refractive index of medium 1. Yes, Aishwarya, that's correct. Mu2 is refractive index of medium 2. But when I say 1 mu2, it is refractive index of relative 2 with respect to 1. Yes, that's correct. Correct. Now, angle of deviation, very important. See, if this is the incident ray and it has some angle of incidence I, and let's say it refracts and this is the angle of refraction, the ray was going like this and it wanted to go along that blue dotted line. But because of the medium change, the light bent and it went there. So there is some deviation, that is delta. Just like a mirror can deviate your light, same way a medium will deviate your light, and that delta over here is very obvious. If this is I, think about it, even this angle will be I because these are opposite angles. So what will be delta? Delta will be R minus I, but it depends who is more, who is less, depending on who is dense or who is rare. So that's why bigger minus smaller. So the positive value, whatever you get, bigger minus smaller. So I'll put a modulus out there. Is that clear? Very good, Khushbu. Glad you are recovering and all the best. No problem, Princey. You have missed probably 10 minutes. Quickly recap. Quickly, you can, even in a live session, you can quickly go back and you can catch up with 2x speed. Don't worry. No problem, Samiksha. Remember one thing, the bond which we form here is not for 1 year or 1 month or 2 months, it's for lifelong. You are always welcome to this channel, and you should become a mascot for this channel as well. And probably you should inspire the younger generation to follow all of us out here at Vedantu. Okay, let's do this question. Let's do this question, guys. Come on, let's do this. Have I seen? No problem, don't worry, even if you're in 10th. A ray of light having wavelength lambda, frequency f, is incident from a dense to a rare medium. Angle of incidence is I. Then the refracted ray in air will have multiple options may be correct. Let's see how many of you get this. Mohit, whatever formulas I give you over here in these 3 sessions are important. So all the important formulas I will give you here, Mohit, and I will tell you how to apply it as well with the problems. Okay, so don't worry. Yes, and plus Mohit, one more thing, I'll be also providing you extracts in the description box after this chapter is over, which is a collection of all the important formulas, not just for this chapter, but for every chapter. So after every chapter, in the last lecture, you will find the summary of this chapter with important definitions, formulas, tricks, etc. Thank you, Princy. That's very heartening. I'm so glad. Okay, many of you are saying just be BD. This is both for J21 and 2022 MV, and 2023 and 2024 for everyone. Optics will not change next year. It will be the same thing. Okay. So, well, let's see the correct answer now. But before that, I have a very exciting news. I'll tell you the answer. Many of you got it wrong. Many of you got it correct. Let me tell you about a very cool thing that is going to happen. Guys, we got many requests from many students. Sir, we also want to prepare for CBSE board examination. And we have heard you. Along with JEE, all those students who want to prepare for CBSE board examination, we have clubbed 2 courses for you together. And that is called the JEE crash course plus the CBSE crash course for your upcoming CBSE examination plus JEE mains examination. Yes, you heard it right. And guess what? There will be 45 sessions just for JEE and for the upcoming first, second attempt, and 107 CBSE sessions for your board preparation. And these are live interactive sessions, guys. And also you will be able to watch the replays n number of times if you want to revise. It's not like you watch it and that's it, it's gone. The replay will stay till the end of the examination, till the last day of your examination. The replays are available, so you can watch it even if you miss it or if you want to revise it. And you will also get, yes, the doubt solving. Let's say there is a exercise question in the NCERT and you do not know the solution or you want to confirm it. Our doubt experts will help you out with the solution for all the CBSE questions, including JEE mains question. So anytime you have any doubt, you can ask us anytime from 8 o'clock to 10 o'clock and get your doubt solved instantly. That's very important. And this crash course has yes, a price of 12,000 rupees. But since you're attending this YouTube class out here with me, we are going to give you a discount of, so that 20% discount. So you will get this course for 9,600 only. Guys, this is crazy. I mean, 45 sessions, JEE, and 100 plus sessions for, CBSE boards, plus special sessions, plus doubt clearing, plus test series, plus discussion. Kaun deta hai bhai? Who gives so much? I am like really astonished. I mean, per session cost will be like peanuts. I think you can buy, literally you can buy few peanuts if you calculate the cost per session, and if you take into account the special sessions and the test series. It's crazy. So guys, the link has been shared below. Join it today because this is a very special batch for all of you. So seats I'm pretty sure this is going to be a very popular course. So it's a limited time course. Maybe it might not come up again because 107 sessions is a big time. So this is a very special crash course which has been launched. So go ahead, click the link and use the coupon code, which is the coupon code SHCC21, guys. Yes, use that coupon code and register yourself. And if you have somebody who will be benefiting from this crash course, definitely tell them. Cool. So the correct answer for the previous question is B and D. Some of you are right, some of you are wrong. Now let me tell you why it is correct. So guys, remember frequency will never change from a dense medium, okay, from a dense medium to a rare medium. So this is how it is. This is angle of incidence, this is angle of refraction. The frequency will not change. So hence frequency is F is correct. Wavelength, okay, now think about it. If you are going from dense to rare, what will happen to the speed? Speed will increase. And remember what was speed? Speed was frequency multiplied by wavelength. Frequency didn't change, so what will change? Wavelength will change and it will increase. So that's why the wavelength will be more. I hope this is clear. Next, speed is more than lambda f. That is also very obvious because lambda into f will give you the speed in the dense medium. Think about it. It will give you the speed in the dense medium. Now, in the rare medium, what will happen? The speed will be higher than that lambda f. That's it, which is correct. So hence speed is more and the angle of refraction is more than I. That is very obvious because it is going from dense to rare. I hope this is clear. Yes, excellent. Yo, everybody understood it? If you understood it, say yo, yes, bingo. Yes, let me know guys. Excellent. Let's get going to the next question. Very interesting question. A beam of light passes normally through a slab whose refractive index is given and thickness is T, and another ray passes outside the slab. Then the difference in the paths between the beams is very interesting. Very good bingos and yos. Let's first think about the diagram for this question, how it will look like. See guys, there is one ray of light which is passing through the glass slab. Do you see that? Another ray of light will not pass through the glass slab. Now, if I label these rays, for example, I label this ray as ray number 1 and if I label this ray as ray number 2, who do you think will be ahead once both of these rays have passed this point? Which ray will be ahead of the other? Come on, think about it. Which ray will be ahead? Will it be ray number 1 or ray number 2? Think about it. Excellent, Yeshwara, Dinesh, Kritu. Very good, Gayatri. Very good. It will be ray number 2. Why is it 2? Because ray number 1 will get slowed down. Why will it get slowed down? Because of the dense medium. Now think about it. What will be the speed inside the glass? I will call it C1 and the speed of light in vacuum is C. We just saw that refractive index, alright, is nothing but speed of light in air upon speed of light in that medium. So C1 will be nothing but C divided by mu, but how much is the value of mu? 1.5, that is 3 by 2, so it will be 2C by 3. So you can see that the speed of light in glass is less than C, 2/3. Now, how much time does it spend inside the glass? So ray number 1, time inside the glass, how much does it spend? Time is distance, which is T, divided by speed, which is C1. So if you divide this, what will you get? T divided by 2C, that 3 goes upstairs. This is the time which it spends. Meanwhile, this ray number 2 would have gone much ahead. How much distance did it cover? So ray number 2, distance by ray number 2 in that time, how much distance did it cover? That will be, this time, which is 3t by 2c into the speed. What speed is it moving? It is moving with c only. So it has gone 3t by 2. I hope this is clear. It has gone a distance of 3t by 2. Is it understood? Time into speed, okay, will give you the distance traveled. Now think about it. Ray number 2 has traveled a distance of 3t by 2, but ray number 1 has only traveled a distance of t in that time. So how much is that difference? How much is that difference between them? So the difference between them is obviously 3t by 2 minus t, which is nothing but t by 2. Correcto. Excellent. Understood how to solve these kind of problems? There can be another problem where instead of the second ray going through air, the second ray goes through another glass slab. That's simple, guys. Again, solve the same way, just that distance traveled by the other ray, when you calculate it, the speed will be different. That's it. So be careful. So solve these kind of questions by simple distance, speed and time method. Nothing great about these questions, but you should know how to solve them. Yes, the answer is t by 2. Next interesting question. A light ray, okay, enters a solid glass sphere of refractive index √3 at an angle of incidence 60 degrees. The ray gets reflected as well as refracted at the surface of the sphere, and you have to find the angle between the reflected and the refracted ray at this surface. Quickly scribble the diagram. How will it look like? Because diagram won't be given to you in this question. That's how JEE KVPY works. They will not give you everything. You have to figure out how the diagram looks like. Are you able to figure it out? Well, let me help you. First, imagine a sphere. Okay, so there is a light ray which is incident at 60 degrees. Okay, so there is a light ray which is incident at 60. So remember, think about an imaginary normal over here, and that angle is 60 degrees. And that ray gets refracted inside and partially gets reflected. The red is reflected, the black is refracted. And obviously the last thing, I'll show the normal. Now I can start solving it. Let's see how do we solve it. First, what do we know? This angle. Do I know this angle? The angle of incidence is 60 degrees. Cool. This angle of incidence is 60 degrees. Everybody is understanding this? Cool. Now, do I know this angle? R. Do I know this angle? Not yet, but I can find it out. How? Sine of 60 divided by sine of R is equal to refractive index, which is √3. Sine 60, how much is it? √3 by 2 sine of R is equal to √3. √3 will cancel. Do you see that? √3 will cancel. Therefore, I will get sine of R is equal to just half. Therefore, R is 30 degrees. Now, if R is 30 degrees, no problem, no problem. It's okay. Even if your net connection went off, you can always switch back few minutes and catch up whatever you have missed. So this R is 30 degrees. Do I know this angle? This angle over here? Yes. How? Laws of reflection. Angle of incidence should be angle of reflection. So it should be 60 because it is reflected. Now things are very simple, guys. If this is 60, this is 30, how much is this angle? Come on, 180 minus 60 minus 30. How much is it? 90 degrees. That is the answer. Very good. Some of you got it. Some of you got it. No problem, no problem. Even if you got the wrong answer, it's okay. But yes, the answer is 90 degrees. Yes, understood? Beautiful question. So this is the angle between the reflected and the refracted ray. So guys, I hope you are realizing optics involves a lot of geometry. So please revise all the properties of a triangle, parallel lines, square, parallelogram, properties of different circles, theorems involved in circles, angles involved, line segments, etc. So you need to be very clever at this. You should be very good with geometry. Only then you will be able to solve these questions. Yes, the answer is 90 degrees. Now let's talk about total internal reflection. Yes, total internal reflection. So guys, I know sometimes it becomes easy because probably I am here. So don't worry, I'm going to make all the difficult stuff also easy for all of you. Now, imagine a situation when light is going from dense to rare. From dense to rare, what happens? The light bends away. Now that can create a problem sometimes. Yes. So I'll tell you how it can create a problem. Look at this. The angle of incidence is slowly increased. Now, whenever light is incident, a part of it gets reflected and a part of it gets refracted. Just like that sphere problem which I showed you. It always happens. Whenever you see through a glass, do you think all the light will pass to the other side? Obviously no. Will all the light get reflected back? Obviously no. Partial reflection and refraction always occurs. You will see that. So imagine this, guys. When light is incident at a small angle, this is refracted and this is reflected. You slowly increase the angle. The refracted angle also increases. And eventually you reach an angle where the refracted angle is 90. Beyond that, you will see there is no more refraction that can occur, because maximum refraction has occurred and all the light has no other option but to get reflected internally. So understand, there is a critical angle after which the entire light gets reflected. Before that critical angle, what happens? Both things will occur, reflection as well as refraction. So that critical angle is what we are interested in. Yes, I hope this is clear. I hope this is clear. Yes. So let's figure out the formula for that. So guys, the formula for that is as follows. If this is a dense medium and if this is a rare medium and this is that critical angle for which the refracted angle becomes tending towards 90 degree, then that is called as the critical angle, because anything up after this will make the rays completely go inside and reflect itself. So if you have to write down Snell's law, how will it look like? Sine IC divided by sine 90 degrees, which is 1, I'll put it later on, is mu dense, because light is going from dense to rare, correct? Sine 90 is 1. So therefore sine of IC is mu dense rare. But generally the refractive indices are not given from dense to rare. When I say refractive index of glass and if I say it is 1.5, where did the light come from? It came from vacuum, isn't it? Usually the refractive indices are more than 1, because we start from rare and go to dense as a standard, as a standard, correct? So understand, we will take the reciprocal of this and this will become mu and this will become rare over here and this will become dense. And this is also a very important formula. You should know this. 1 mu 2, you should know this formula, guys. 1 mu 2 is same as 1 by 2 mu 1. This works. This always works, because 1 mu 2, think about it, is nothing but mu 2 by mu 1. And what is 2 mu 1? It is mu 1 by mu 2. So they are reciprocals of each other. Yes, they are reciprocals of each other. So usually we will remember this formula. This is that formula which we'll remember. Sine of that critical angle is 1 by refractive index. 1 by refractive index is sine of critical angle. Remember this. Relative refractive index of dense medium with respect to rare. Okay, come on, remember this. Everybody done? Shall we start with some problems? Are you guys excited now to solve some problems? Shall we proceed? We'll go ahead. Okay, cool. Come on guys, show some josh. And if you have not yet liked the video, please go ahead, like that video. And if you're a new user, please interact with other students, make friends. And the only way you can mark your presence out here is by getting involved in the discussions out here. Yes, and also hit the subscribe button. You will not miss the next lecture. Okay, now this is a very cool example of where total internal reflection is used. You will see that if you pass a laser beam through this cylindrical glass tube, you will see that if this refractive index is very high, then the light will get reflected even for small angles. Look at that. It will get reflected even for small angles. So the light does not come out, it just bends and it will just stay inside. And this is how optical fiber network works. Yes, correct. So the principle of total internal reflection is involved over here, because of which the light does not come out, because of the high refractive index, and the electromagnetic waves travel within this medium till the other side. Yes, correcto. And this is another example, guys, Mirage. So some of you would have experienced this when you have been to a desert or seen an empty land with a lot of hot air around it, you will see that in a special situation when this air is very hot, the air above is very cold, you will see the refractive index changes because the colder air is dense, the warmer air is light, and understand it is basically having low refractive index. So those rays which are coming from some object, they are going from dense to rare, so they will bend till a point, they get internally reflected. Yes, there is a point till which they can keep on going like this until they get internally reflected, and then they come like this. Remember, they are going from rare to dense here, and from here to here, dense to rare. So they are bending away from the normal, from this point to this point. So this creates an illusion as if the tree is over here. People feel that the tree is here, but actually the tree is not here. That is just the way the rays enter your eye. So mirage formation happens because of total internal reflection. Ritesh, don't spam. I won't answer the question if you spam. First you apologize, first you type an apology, and then you ask the question once, then I'll answer your question. Light is a wave or a particle. Saurav, I made an excellent video on that. Does reality exist when you do not see it? So that lecture will answer your question. Please go ahead, watch that lecture, very important lecture. Okay, so Ritesh, the thing is, I will be taking flash or sprint series for class 11th. In fact, most of the portions have been completed. Okay, few topics like thermo and waves are remaining. I'll be completing it in the next few weeks. But for the remaining parts like fluids, errors, mechanics, rotation, circular, work, kinematics, etc., please go ahead, check the playlist. All the lectures have been systematically arranged with the PDFs, with the summary, and with the problems, everything. Okay, you can do that. I hope that is clear. Yes, cool. Look at this. This is also a mirage. This is also a mirage. Yes, look at that. That's how mirages look like. I hope, Ritesh, that has answered your question as well. Now let's solve this question. The critical angle of a medium is 60. What will be the deviation when the angle of incidence is 30 in the denser medium? Come on, think about it. Hi Brajesh, welcome. What will be the angle of deviation when the angle of incidence is 30 degree? Come on, let's try and solve this. First, let's draw the diagram. Okay, now first over here, okay, this is the diagram. When the angle of incidence is 30, I don't know what the deviation is. Think about it. For finding the deviation, I need to know the angle of refraction. To find the angle of refraction, I need to know the refractive index. How do I find refractive index? By this information. Critical angle of that medium is given. Remember that formula I just told you? Sine of IC is mu, 1 by mu, correct? So the critical angle is 60. So therefore sine of 60 is 1 by mu. And what is sine 60? Root 3 by 2 is 1 by mu. Therefore mu is 2 by root 3. Cool. Now be very careful. A lot of students are going to make a mistake over here. No problem, Gayatri. It's okay. You will soon catch up. Okay. So over here, this angle is 30 degrees. This angle is 30 degrees. I want to know what is this angle. First, let's call this as R. So if I say sine of 30 divided by sine of R, please be careful. It is nothing but you are going from the dense medium to the rare medium. This is dense and this is rare. You are going from dense to rare. But this mu is not dense to rare. It is rare to dense. Think about it. 2 by root 3 will be more than 1. 2 by root 3 will be a value which is more than 1. So in fact, this is nothing but rare to dense. So guys, the value of mu that you will be substituting. Yes, refractive index can be less than 1, but relative refractive index only, Saurav. Only relative. Absolutes are never less than 1, they are always more than 1. Okay, so be careful. This mu that you found out is nothing but your usual refractive index, which is more than 1. You can see that this is more than 1, isn't it? So guys, the value that you will be substituting over here is 1 divided by 2 by root 3. That is what you should be careful about. Yes, yes. And sine 30 is half, and this sine r will come down as it is. Okay, so 2 gone, you can see that 2 and 2 gone. So therefore sine of r will be 1 by root 3. Therefore r will be sine inverse of 1 by root 3. Cool. Now last part of that problem. What is angle of deviation? Angle of deviation, remember, was bigger angle minus the smaller angle. Here the bigger angle is r minus the smaller angle is I. So over here it will be nothing but sine inverse of 1 by root 3 minus angle of incidence is 30 degrees, which is same as pi by 6 radian. That is the final answer. I hope this is clear. This is the final answer, guys. Is this understood? Check it out. If you still have doubts, you can ask me. Cool, cool. No, Bastian, think about it. Be careful. Sine of any number can't be more than 1. Sine of any value has to be less than 1. Sine r is not root 3. Remember, this was 1 by root 3. So root 3 will go up. This is same as root 3 by 1 or root 3 by 2. So that 2 got cancelled. So when I flipped it, root 3 came below. I hope that is okay. Bastian, is that fine? Cool. Yes, let's get going then. Ritesh, nobody knows the JEE weightage of the topic because JEE will never give you the weightage, but every year there will be at least 1 or maximum 2 questions from this, and you know that JEE has hardly 25 to 30 questions in one subject, so you can see that if something is having 1 or 2 questions, that's decent enough. Because there are number of topics only are like around 40-50 topics are there. So the number of topics are more than the number of questions. So usually they can combine the questions from 2-3 chapters into one question. Okay, cool. So that is the answer. We got this. Cool. Let's get going. Look at the next question. An isotropic source. An isotropic source is placed at a depth of h below the water. A floating opaque disc is placed on the surface of water so that the source is not visible from the surface. What is the minimum radius of the disc? Take the refractive index to be mu. Let's see. Yes, VK, there are a lot of kids playing outside my society, and you know that I'm not in the actual Vedantu office. And thank you, Prem. And by the way, VK, let me tell you, few days back, when I was conducting a normal class, on the Vedantu platform, students heard these kids' noises and they were like, sir, can you please show your kids? I'm like, kids? Like how many kids? They're like, sir, I think you have some 5 to 6 kids at least. I'm like, no, I don't have 5 to 6 kids. I just got married few years back and right now I don't have kids. And they suddenly made me the father of some 4 to 5 kids. I'm like, what the hell? Okay. Hi, Ankit. What happened? Yes, you have made all the notes. Very good, very good. Cool. So let's see how to solve this question, by the way. So guys, this is that water, this is that air, and there is a source below. Now that source will emit light in all the directions. Only some light will be able to come out. Some light will get reflected inside. How? Look at this. The rays which are going like this will obviously come out. No deviation at all. The ray which is going like this will get away from the normal because dense to rare, correct? Next, there will be one point where the ray is just coming out. That will be the critical angle, obviously. And any ray after that will get internally reflected. So all the green rays will come out. The black is the limiting. Red ones will get reflected. Now this will happen everywhere. Visualize this. Visualize this on that surface, guys. This will happen everywhere on the surface. So if you make a disk of this size, what will happen? You will block all the light which is coming out. And if you block all the light which is coming out, the other light, the red rays, are anyways not coming out because they are getting internally reflected. So hence guys, you need the disk whose size is exactly this much. Exactly this much. This is that radius that you need. And what else is given? What else is given? This height h is also given, guys. This height h is also given. And think about it, what else is given? Well, this angle will be the critical angle, IC. If this is critical angle, obviously this angle over here should also be the critical angle. Opposite, alternate angles. These are two parallel lines. If this is IC, this is also IC. Okay. Yes, Ankit. Yes, I do. Okay. Now, I'm not sure, Kishore, for what are you saying, congratulations, but let me proceed ahead. What is the formula for critical angle? Sine of IC will be, by definition, 1 by mu. I just told you the formula, correct? One more interesting thing. By geometry, look at this triangle. Which triangle am I asking you to look at? Look at this triangle. Look at this triangle. If you look at the triangle, what will you see? Tan of IC is R by H, opposite by adjacent. Now, here is one interesting hack which you can use even in maths. When you have sine and tan, or cos and cot and something else, sine and cosec, something else. So you want to convert from one to other, draw a simple triangle that will avoid all the confusion. This is critical angle. Sine is opposite by hypotenuse. If that is the case, then by Pythagoras, this side must be root of mu square minus 1 by Pythagoras, isn't it? Now, I can immediately find what is tan of IC. Think about it, tan of IC will be nothing but 1 divided by root of mu square minus 1, opposite by adjacent. And that is tan of IC, guys. And that is R by H. But the question is to find R, so it will be H divided by root of mu square minus 1. And that should be the answer. Is that clear? Is that clear? Yes. Yes, that's how simple it is to solve the problem if you use proper geometrical techniques. So you will learn all the geometries, theorem, etc. Then definitely you will be able to solve the problems really quick. Oh, for that, thank you, Kishore. Thank you so much. Thank you, Kishore, so much. I'm glad. And it's all because of your love and your support, guys. That's it. It's pure hard work plus your support and love that I get. Thank you, guys. So, by the way, this answer is correct. And let's get going to the next question. What do you see? What do you see? No problem, Muhammad, yaar. Don't worry, I know you're from Kashmir, most likely, and most likely that net goes on and off. A lot of Kashmiris were complaining that the net is very slow. No problem, don't worry. You can watch it slowly as per your pace. Okay, you can see a crystal, you can see some insect. Okay, yes, this is a fossil of some insect, and you will see that this fossil has been preserved in a translucent kind of a glassy material, and the image that you are perceiving now is not the actual size of that insect inside it. The actual insect might be bigger or smaller because there is refraction that is happening. So just by measuring the size from outside without having to break the stone, you can figure out what is the actual size of the insect. And that's what we are going to do. That's what we are going to do. So let's start with the concept. And before that, one more example. Look at this curved glass paperweight. So whatever is inside is actually probably very small. Yes, it's not so big. Just because of the refraction, you see a magnified image. That's all. And even the meniscus which is formed on water, if there is some dirt or some insect deep inside, and if you see it from the top, you will see it differently, probably diminished or magnified depending on the curvature and whether it is convex up, convex down and all that. So guys, what we are going to study now is not a plane surface refraction. Remember, all the problems that we solved before this involved plane surface. Now we are going to study curved surface refraction, but only refraction at one surface. In next to next class, what are we going to study? We are going to study refraction at both surfaces, two curved surfaces. What is it called? Lens. So that's how we slowly build up the concept. We started with plane surface, then curved surface, then two curved surface, then two flat surfaces are prisms, and so on and so forth. Don't worry, we are all going to see all of this. So this is how the refraction can happen depending on which is dense, which is rare. So let's say over here, there was an object, okay, and the rays come out like this, and at this curved surface, you can see the light rays are bending. Can you guess who is more? N1 is more or N2 is more? Can you guess from here who is more? N1 is more or N2 is more in the first diagram? Yeah. So think about it. Think about it. Yes, which is more? Yes, Snell's law is valid for curved surfaces also. Yes, think about it. If you draw a normal over here, things will be very evident. If you draw a normal, this is angle of incidence and this is angle of refraction. Is Snell's law valid here? Yes, it is valid. Snell's law is valid at even curved surface. But you have to draw a normal and only then you can make it valid. So now you can clearly see that R is small, so this should be denser, this is rarer. So obviously N2 is more than N1. Yes, most of you got it correct, some of you got it wrong, no problems. It's okay, it's okay. So now let us see the formula for this. If you have an object in front of a curved surface, the image will be formed on the other side, and the image which is formed on other side, it could depend, guys. It could be on the other side, it could sometimes be on the same side also, whether if it is real or if it is virtual, it completely depends on that actually. So if you have an object, if you have an image, then I want to know what is the relationship between them. So let's see the very important formula, and lot of you are going to make a common mistake, so please avoid that. And let me tell you how to exactly look at these problems. See guys, if you have a curved surface, the first thing that you should think about is the pole. The pole is over here. That blue line over there, this one, okay, this is the principal axis. Okay, this is the principal axis. Okay, then see how the rays are going. The rays from the object, since this is the object, since the rays are going towards that side, so you are going to make sure that your x-axis is over there, and this is your upward direction, that is y-axis, and this is the origin. This is the origin. Finally, in this situation, the image was formed over here. The image was formed over here. Now, if these things are clear, remember there is something like object distance, image distance, etc. So think about it. As per this, is the object distance positive or negative? Is object distance positive or negative? Come on guys, let me know in the answer. Let me know in the chat box whether object distance is positive or negative. Come on, think about it. Yes, it's negative, Aishwarya. Correct. So Fida, it depends on how the rays are falling. So see Fida, if this is a curved surface, if the ray falls like this, then if this is 90, this is also 90. But if the ray falls like this, then it can bend. So this angle and this angle may be different. So it depends on the angle at which it is falling, Fida. Yes, it's negative. And image distance, guys, what about image distance? Is it positive or negative? Think about it. Think about it. Image distance will be positive or negative. Think about it. Yes, correcto, it is positive. And if I ask you, radius of curvature, is it positive or negative? Radius of curvature, is it positive or negative? Yes, it is still positive, because the center of curvature will lie somewhere over here. and this is that radius of curvature. This is that radius of curvature. Check the coordinate of center of curvature, and it is positive, so that radius is also positive. Excellent. Now if you have understood this, let me give you the formula. The formula is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is that standard formula which you should know. Okay, so this is something which you should know. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Now, what is mu2 and what is mu1? Let me tell you that as well. Mu2 is refractive index of that medium where there is refracted ray. Where there is refracted ray. Very, very important. And what is mu1? Is the medium where there is incident ray. That's very important. Now, I'll tell you, many people by heart this formula in a wrong manner. They by heart this like this. Mu2 is refractive index where there is image. Mu1 is that refractive index where there is object. Sounds good. Sounds good, because mu2 is where, you know, the image is, mu1 is where the object is. But this might not be always true. Why? Because in this situation the image was formed here. What if the image was virtual? And what if the image was formed over here only for some reason? Then what will you take mu2 and mu1? Will you take the same value of mu? Obviously not. Understand that. So it's very important for you guys to remember that these refractive indices are dependent on the ray and not the image. On the ray, correct. R is the radius of curvature. Yes, Saurabh. R is that radius of curvature. See this? The same R. Radius of curvature. Correct. Okay? That's one thing. And last thing, one last formula, the magnification formula. How much does it get magnified? Very important. So normal formula for a mirror was V by U with a negative sign. Remember, wherever there is a minus sign in reflection, in refraction that minus sign goes away. So it will be plus V by U, but there is one extra term. In this formula, which refractive index comes with V? Mu2, correct? So V by mu2 like this and U by mu1. So basically it just becomes V mu1 by U mu2. U mu2. V mu1 by U mu2. That's the formula. No minus. No minus. No minus. Be careful. Minus is there in mirrors, not in refraction. Be careful, guys. Yes, be careful. Oh yes, I do remember Kishore. Yes, I do remember Kishore. Is that clear? So that's what I'm telling. Wherever, see, mirror formula and lens formula are very similar. Mirror formula is 1 by V plus 1 by U is equal to 1 by F. Lens formula is 1 by V minus 1 by U. Magnification in mirror is minus V by U. Magnification in lens is V by U. So that's the change. Okay, be careful. Okay, cool. Let's start solving some problems. Come on, guys. Here is the question. A spherical surface of radius r separates air from the glass. The center of curvature of the glass is in the glass. Sorry, the center of curvature is in the glass. A point object is placed in air, and the real image is formed inside the glass. Line PQ cuts through the surface at point O, and PO is equal to OQ. The distance PO is equal to. Let's see. How do we solve this? Let's see how do we solve this. Now first draw the diagram. That's very important. Let's start with the diagram, guys. Okay, come on with me, guys. Come on, show some josh. Come on, keep participating. First, this is the curved surface. This is the dotted line, which is the principal axis. Where is the object? If you draw the diagram, believe me, it is a 1-2 line solution. That's it. Where is the object? The object is placed in air. That means the object is here. Where is the image? The image is in the glass because it's a real image. So the rays from the object merge back over here. Cool. Then this line PQ cuts the surface at point O. Okay, that means this is object, this is image, it cuts the surface at point O, and this is the radius of curvature. I hope this is clear, guys. I hope this is clear. Now just start marking the distances and let's see what do we get. First thing first, this distance, this is where the object is. This I will call it as X. Naturally, this distance is also X. Why? Because it is mentioned PO is equal to OQ. PO is equal to OQ. That is done. Cool. From the object, how will the rays come? The rays will come like this. They will refract and they will enter into this medium like that. So this is incident rays. These are incident rays, these are refracted rays. Cool. Now, who should be mu1 and who should be mu2? Think about it. Incident is always mu1. Which is this medium? Air. So mu1 will be 1. Think about it. This is in air. And where is the refracted ray? Refracted ray is in glass. So mu2 should be how much? Glass refractive index is 1.5. Cool. It is 1.5. Is that understood? Is that understood? Yes. Correcto. Now, think about it. Think about it. What will be the formula? The formula is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. So let's use this formula and see what do we get. Let's use this formula. Mu2, just use this 1.5 by V image. Should it be positive or negative? Lot of you are going to answer negative, but be careful, it is positive. Image is formed at a positive distance. You will be like, sir, what the hell? I thought it was left side. Think again. Think again. Why is it positive? Because our x-axis will be here. This is the origin, isn't it? Our x-axis is over here. Think about it. In the direction of incident rays. That's where many people get it wrong. Is that clear, guys? Everybody understanding this? So yes, it will be plus x minus mu1. What is mu1? It is 1 by u. What is u? It is minus x. Be careful. Why minus x? Because look at that. Object is on the negative side of the positive x-axis. Mu2 is 1.5 minus 1 divided by r. Is r positive or negative? Think about it. Is r positive or negative? Yes, think about it. Is r positive or negative? Thank you, Sandesh, so much. Thank you for so many hearts and love. Thank you. Because of all you students, I get all the motivation. Thank you so much. Keep studying like this only. God bless you. Okay, R will be positive. Very good. Because the center of curvature is here. Check the coordinate of the center of curvature. It is positive. Correcto. Now solve this. Minus minus is plus. So it will become 1 by x is common. Okay, 1.5 minus minus becomes plus 1. Okay, and this will become 1.5 minus 1 is 0.5 divided by r. So this will become 1 by x. 1.5 plus 1 is 2.5. 2.5 is 5 by 2. And 0.5 is nothing but half. Okay, 2 goes. So 5 by x is equal to 1 by r. So naturally, you can see x is equal to 5r. That is what exactly we wanted. How much is that distance? The distance PO is equal to how much? We got it. Did you understand? So many concepts were there, guys. So many concepts were there. Very good. Yes, fire is the answer, Yalni. Fida, very good, Shihari. Excellent. Let's get going to the next concept. Yes, that's the answer. Now, last part of today's class, last part. So let's solve this. Apparent depth questions, and I'm going to give you a beautiful formula. After this, you will never face any problems. How many of you face problems in apparent depth questions? If you are facing, believe me, after this you will never face any problem, guys. कुछ नहीं है. if you are hunting a fish, hopefully not, we don't go back to those days, okay? If you see the fish somewhere, please don't hit it over there because the fish is not actually there. It's going to be much deeper, and that is because who is fooling you? Refraction. The rays from the actual fish, this is a real fish, refract because it's going from dense to rare, and you perceive the light coming from there, so you feel that the fish is little bit up, it's closer to the surface, but actually it's much deeper than what you actually see it to be. So the apparent depth, Ankit, now I'm going to tell you, now there is a very interesting thing out here. The thing is, if you are a bird, imagine you are a bird, okay? Imagine, or let's say we have Champa over here and we have Pandu over here. This Champa is like that bird, this Pandu is like that fish underwater. Pandu is like a fish underwater, Champa is like a bird in air. When Champa sees Pandu, Champa will see Pandu is hardly at any depth. She'll feel, hey, what the hell Pandu is doing? He's near the surface. But actually Pandu is much deeper. Is that clear? But if Pandu sees Champa, look at the rays coming from Champa, guys. It will bend and it will go like this. So if Pandu extends the rays backwards, he will see Champa here. He'll be like, what the hell is she doing? Why is she standing on such a tall building? He'll probably come out of water and try to save her. Isn't that right? I'm pretty sure you will do the same thing. So understand, a fish sees the bird higher than its actual height, and a bird sees the fish at a depth less than its actual depth. Is that clear? Yes, a lot of April Fool happening out here. Tanish will be starting JEE 2023 very soon, in a couple of months, for sure. Yes, we'll be coming up with a plan after March, for sure. Yes. So now, what is the formula? I'll give you a beautiful formula. After this, you'll never forget it. If this is the dense medium, this is the object, and the object is seen from a rare medium. You are the bird, you are watching a fish. Fish will be seen on the top. So what will happen, guys? This is actual height. Okay, this is actual height or depth, whatever you want to call it. Okay, and this is apparent, what is seen. Okay, it is apparent depth, so I'll call it h prime. Then understand, h prime will be h by mu. Isn't this obvious? Like, mu is a bigger number, larger than 1. So when you divide it, this value is going to be less than h. If height was 10, when I divide it by mu, which is more than 1, obviously I'm going to get a value which is less than 10, which should be correct. Look at that, apparent depth is less. Is that clear? So this is the formula when you are a fish and seeing, when you are a bird and you are seeing fishes. So when you are a bird and seeing fishes, yes Ankit, that's the reverse case. Now, if you are a fish and seeing a bird which is actually here, you will see that that bird is much higher than what it is supposed to be, and that, Ankit, should answer your doubt. If this is your actual height, think about it, and this is h prime, which is your apparent height, in this situation h prime is more than h, and you have to multiply by mu. Remember that. Multiply, because this is more and this is less. Is that clear? Everybody understood this? So the thing is, why does it vary with viewing angle is because, see, if this is that object, the rays are going to come like this. Okay, so if you are here, you might see it here, but if you are here, then probably you might see it here. That's why you might see some difference. I hope that answers your question. Yes, if you're underwater, correct Fida, you will see an object further away, correct. Okay, now look at this. I hope you can visualize what this is exactly. This is nothing but a glass slab, and the table surface appears closer. Haven't you felt that? Haven't you felt that when you take a glass piece and slide it over a table, like a paperweight or something, you will see that the table surface appears closer. And if you take that glass slab and see anything around you, you will see everything has come little bit closer. Yes, even though it is a glass slab. And that is called as the shift, which happens when you view anything from a glass slab, guys. So what is that shift? Very simple. If a glass slab is there, then understand when you see anything from the other side, this glass, because it is denser, imagine, this surface, this top surface will appear closer. If you are down here and if you see, because you are seeing something in the denser medium, it will appear closer. Everything behind it will also appear closer. So the glass will become thinner when you see it from here, and everything behind it will also appear closer to you. So there is a shift which is happening. You can see that very clearly. And that has happened because this surface appears to be over here. So there is a shift. So this shift can be easily calculated, guys. If this is h prime and if this is h, okay, that shift is h minus h prime, and that h prime is h by mu. Understand, this h prime is smaller than h, so divided by mu. So you will get it as, oh my bad, so sorry guys, I put a wrong formula out here. I'm so sorry. 1 second. So sorry. So how do we calculate that shift? Sorry, this was not h and h prime. My bad. So if this is nothing but that shift, okay, if this is nothing but that shift, here is how we are going to do it. If this is h, which is the thickness of the slab, so this is the thickness of that slab, then this point will appear to be over here. It will appear to be over here because you are a bird seeing a fish. It will appear closer, shallower. So this is nothing but h prime or h1. And whatever shift happens here, everything behind it will be pulled by the same amount. So that's why whatever shift happens here is also the shift behind that. I hope that is clear. Yes, now you can get it. That shift will be h minus h prime, and h prime is h by mu, and this will be h into 1 minus 1 by mu. So this is the formula for shift, guys, which you should know. H is the thickness of the slab, mu is the refractive index. Everything behind the slab will be shifted by this much amount. I hope this is clear. Everybody okay till here? Excellent. Cool. Chalo, let's solve a question based on this. This is the last question. I'll be giving you other question as homework. Okay, so come on. Let's try to solve this question. A vessel of depth 2h is half filled with a liquid of refractive index 2√2 and upper half with another liquid of refractive index √2. The liquids are immiscible. What is the apparent depth of the inner surface of the bottom of the vessel? These are the options. Don't worry about the options. Think about the value. I'll tell you how to solve this. Well, I'll give you a simple way to solve this. See, the question is basically, you are here. You want to see where would the bottom part appear. Because you have to find what is the apparent depth of the inner surface of the bottom liquid, the container. Here is my logic. Guys, can't we treat them like glass slabs? This is like slab 1. This is like slab number 2. Isn't it like slab 1 and 2? Each slab will cause a shift. Isn't that right? So find the total shift. The total shift will be shift because of 1 plus the shift because of 2. Isn't that right? And what is the shift because of slab 1? Well, this height is h. This slab thickness is also h because they are equally filled. So it is h into 1 minus 1 by mu. What is mu? Mu. It is 2 root 2. 2 root 2. Shift because of 2. H into 1 minus 1 by another refractive index, which is nothing but, root 2. So think about it. Let's arrange this. So this will become 2h minus h by 2 root 2 minus h by root 2, which is nothing but 2h minus. Okay, I can take LCM, multiply and divide by 2, and that's how I can take LCM. So this will become 2 root 2, h is there on the top, minus h minus 2h is minus 3h. So it will become minus 3h, I suppose. So that is nothing but the total shift. So this point shifts by this much amount. But that is not the question. The question is, what is the depth? This is the depth. This is the depth. So guys, think about it. What will be the depth? The depth, this much will be 2h minus the shift. This depth is total minus the shift. So total is 2h minus this shift, which is 2h minus 3h by 2 root 2. Okay, 2h goes, minus minus becomes plus, so it will become 3h by 2 root 2. And if you would wish to rationalize it, multiply by root 2 and divide by root 2, so it will become 3h root 2 divided by 4. That is the answer. That should be the answer. Correct. Very good. Some of you got it. Very good. Very good. Very good. Very good. Understood, guys, how to solve the problem of multiple liquids? Treating them like glass slabs. Treat them like glass slabs, you will get the answer. Correcto. Are you guys ready for one more question? I wanted to give this like homework. I'm not sure. Should I give it like homework, or should you solve it over here? Should we do this last question and then wind up? Yeah, one last question. Thank you, Prem. Yes, ready? Yes, if you're ready, give me a thumbs up. It will hardly take you 2 minutes. No homework. Okay. Yes, sure. Thank you, guys. Thank you for all the support. Now, this is a beautiful question, and many websites give the answer for this question wrong. That is why I'm solving this question. Many websites give this answer wrong. So, what is happening? There is water filled till 12 centimeters. You are having an object. Okay. Let's see. You have, okay. One second. Yes. You are having an object over here, and that object is at 10 centimeters. Okay. Object is at 10 centimeters above this liquid surface. Cool. And I am seeing that object. Okay. I am seeing that object from the top, and I'll see the reflection of it inside a mirror which is there behind it. Crazy it is. So there is an object here, there is water, there is mirror, and I'm seeing the object's reflection inside the mirror. I want to see how far that image is going to be formed. Let's solve this. Are you guys ready now? Let's solve this. Now, to solve this, I'm going to simplify the problem. How? I'll tell you what. Whenever you see a mirror, remember, whatever is there in front, push it behind, reflect it, open it up. Whatever is there in front of the mirror, open it up, because what does a mirror do? It exactly replicates whatever is there in front behind. So this diagram is similar to that object, that water, okay, and that water will also get replicated, because now that mirror is gone, that mirror surface is gone, guys, and wherever that object is, it will be here. That object is here now. So this object will now be over here. Is that fine? And how much is this distance? This distance is 10 plus 12. So 10 plus 12, guys, that is 22 centimeters. So this object's image, because of that mirror, where will it be formed? Think about it. Where will it be formed? It will be forming 22 centimeters behind. I hope this is clear. Isn't it interesting method, guys? Isn't it interesting method? Now that is not the answer. Yes, that is not the answer. Now you know what you should do. You are over here. You are over here. You are seeing this, but through a glass slab made of water. Think of it like a glass slab, double the size, this plus this. So think about it. What is the size of this glass slab? 12 plus 12. This is 24 centimeter slab, guys. And you are seeing an object through it. What do you think will happen? What do you think will happen? Obviously, this object will shift, isn't it? This object will appear to be somewhere here. And why is this happening? Because it is getting shifted. So guys, how much is that shift? That shift is width of the slab, 24, into 1 minus 1 by mu. What is mu? 4 by 3. This will become 3 by 4. 1 minus 3 by 4, 1 by 4. 1/4 of 24, 6 centimeters. Isn't that correct? So the shift, guys, is nothing but 6 centimeters. From the mirror, this is at 22, the shift is 6. Come on, you should immediately pounce and tell me how much is this? How much is this? 22 minus 6. How much is 22 minus 6, guys? Isn't it 16 centimeters? Isn't it 16 centimeters? Got it? That's the final answer. So you will see it 16 centimeters from the mirror. As simple as that. Yes, that's what you're going to see it. And that's the answer, by the way. Yes, 16 centimeters. And these are our we enthusiasts, our true minions, our mascots, our beautiful supporters, Aishwarya, Surur, Prakash, weird fellow, wow, okay, and weird fellow. Okay, so some of you have posted the answers in the previous video and some of you have truly enjoyed the session. So I just thought, why not post all of your lovely comments out here. So these are our true stars. Obviously, you two are there. Some of you don't post comments. It's okay. I know. Yes. So guys, I have posted the answers in the Telegram group. Check the answers in the Telegram group, Aishwarya. Yes, check the answers in the Telegram group. This is your homework question for today. Solve this and become a star for the next session. I'll post the answers in the Telegram group. All right? Cool. So remember guys, JEE crash course with the CBSE crash course is starting. Yes, and this is going to benefit you for both, for boards as well as the JEE examination. So we have combined both the crash courses together. In fact, it's going to have 45 sessions for JEE and 107 CBSE sessions. And guys, the best part is that you are going to have these sessions as live sessions, plus the recordings will be available till the last examination with doubts. Even if you have doubts in NCERT, even if you have doubts in previous year's questions or HC Verma, it doesn't matter which book, get all your doubts solved. That's very important from morning till night. And this course is a very special course. So it's a very limited edition kind of course because crash course cannot start again after some time, especially for board examinations. So we have made this crash course keeping in mind all the students who want the final push for their boards and JEE examinations together. The course price was actually 12,000, but since you're attending my sessions on YouTube, 9,600 after 20% discount when you use the coupon code SHCC21. Amazing teachers, experienced teachers are going to teach, obviously. So go check out all the details in the description box below. Enroll yourself now. Don't waste more time. That's very important. And if you love today's session, please hit the subscribe button if you have not done it yet. And if you have not hit the like button, then also please hit the like button out there. Thank you guys. Thank you everyone. Tomorrow, yes, Fida, you will be also there on the screen. Yes, Alni, bye-bye. Aishwarya, bye Priyanka. Bye Khushbu, bye Gayatri, bye Princey. Thank you guys very much. Bye VK channel, bye Srihari. Bye-bye. Take care guys. See you again tomorrow. Thank you for all the love and support from all of you. Bye-bye.